Okay, the main thing you want to keep in mind when naming is you gotta come up with a set of rules to follow, and you also want to be familiar with all the different compounds you're going to be exposed to. So, for example, these are a bunch of common polyatomic ions that you can encounter when naming things, and when you're seeing formulas or trying to construct formulas from names. So things like phosphate, sulfate, you gotta know them. You gotta know the charges, and you gotta know what they are. So if you see a sulfate, you know what to name it properly, and you won't, mess up the name. So that being the case, I came up with just some things I always follow whenever I'm naming something, and it's really basic stuff, and it's just really general stuff, and it's not like they're not hard and fast rules to follow. Like, does the molecule have metals? You always want to look for metals, because if it has metals, you're not going to use prefixes, and if it doesn't have metals, you're going to use prefixes. And if you're going to use, if it's something that doesn't have any metal in it, then you're going to use the prefixes, and you got to follow some basic rules for prefixes. And the actual rules are more convoluted than this, but I just kept them really simple. Like, you wouldn't name CO carbon monoxide. You wouldn't call it carbon monoxide. You call it carbon monoxide. You drop one of the O's. And then if you're using transition metals, which cover a broad range of metals, then you want to use the stock system, which is infusing Roman numerals into the name. So we'll do some examples here. Again, keep in mind some of the polyatomic ions, and we'll see some of these to review it. So what is the name for PB3PO42? Well, you could probably start right off by, you can see this is lead. You got PB, which is just basically lead. And you have to recognize you also have a polyatomic ion. So if you don't know that this guy is specifically called phosphate, then you're going to mess it up. You're going to mess up the name. So this is lead 3PO4, or phosphate, and there's two phosphates. Now you also have to know the charge of each phosphate, of each of these phosphates, is 3 minus. Each one is 3 minus. So since there's two of them, that gives you a total charge for these two, plus another PO4. The total charge of these guys is 6, minus 6. So these three leads over here balance out that minus 6 with a positive 6. So that means each of these leads, each one, is positive 2. 2, 4, 6. That being the case, you also have to realize that this lead is a transition metal, so you have to specify the charge of the lead in the name. The way we specify is by using the stock system, or this Roman numeral 2 in the name. So you would call it lead 2 phosphate. Again, the name tells you that lead is a 2 plus charge, because lead can have a couple charges to it. Whereas phosphate, if you're familiar with your chemistry, you'll know the charge of phosphate, so that doesn't have to be outlined. So that's why it's called lead 2 phosphate. What about, what is the formula now for sodium sulfate? So this might not be too bad at first. You might think, a lot of people would make the mistake, something that has to do with NaS. Okay? NaS would be sodium, some type of sodium sulfide. That would be some type of combination of NaS, and that would actually be Na2S. 8 tells you a polyatomic ion is involved. So you definitely have sodium involved, but we have an 8 over here, so that's a polyatomic ion. You have to know what the polyatomic ion for sulfate is. So let me go back to that chart. Sulfate's right over here. SO4 2 minus. So you have to know that guy. So again, that's SO4 2 minus. And I like using the parentheses to separate the charge from the subscript. Superscript and subscripts are completely different things. They mean totally different things. This is charge. This is the number of oxygens you have in this compound, in this polyatomic ion. And you have sodium. Sodium's in group 1, so everything in group 1 is a +1 charge. So it's always +1. Easy way to do this is to write out the ions like so, and then cross the charges downward. So again, what you're doing is you're crossing the charges, you're bringing them down. Now you're not going to carry the charge itself, so you just rewrite sodium, you bring down the 2, you rewrite SO4, you bring down the 1. And you don't have to write out the 1. I'm just going to leave it blank. And that makes sense because you have 2 positive charges to balance out the 2 negative charges. 2 sodiums, each one's a positive, and then 1 SO4 with a 2 minus. The charges balance out, and you always want your charges balanced, always. So that's sodium sulfate. What is the formula for iron 3 or iron 2 phosphate? Again, that's phosphate, ATE, not IDE. IDE is a completely different thing from ATE. So you have to look up what the polyatomic ion phosphate actually means. Phosphate is over here, PO4 3 minus. So we know this guy is a PO4 3 minus. Iron is always Fe. And this Roman numeral here tells you it's 2 plus. This is an iron ion. This is an iron that has a 2 plus charge on it in this compound. Again, that's told by the Roman numeral. The Roman numeral does not tell you how many irons are in your compound. Never. It tells you the charge of that element. Phosphate you have to memorize. You have to memorize its charge. And again, you can cross the charges here and it works out really well. Just again, when you're crossing the charges, do not carry along the actual charge. All you're doing is carrying the number. Just the number. So if you rewrite Fe and rewrite PO4, you bring this 2 over to this side, you bring this 3 over to this side. A common mistake is somehow intermingling the 2 and the 4, having them like mix up with each other. You don't want to do that. Again, that's why I like putting parentheses, because it shows you got to keep this guy alone. He sticks to himself. The PO4 is a polyatomic ion. It stays in that complex. It stays like that. And this makes sense too, because for each iron, this gives you a total charge of, if you were to like split this guy in half, this gives you a total charge of +6 on this side, right? So this gives you, on this whole side, you have a total charge of -6. And that balances out. That gives you a total neutral charge for this whole compound. What is the name for PBS? So what would you name this compound? Oh, you can probably tell if you're at all or if you have a periodic table in front of you, or if you're familiar with these elements. You know there's lead in there. That's the name for Pb. And you know there's sulfur in there. So there's lead and there's sulfur. So how do we name it appropriately? Well, again, you want to keep in mind this is a transition metal. That tells you you have to use Roman numerals in its name. So if you were to just write out these 2 names and you said, okay, let me just add it up. Let me just add to it. So lead, well actually, how would you know what the charge is? I mean, you could say it's 2 based on just experience, but how you got to know for sure. You got to know that guy for sure. So let's not do that yet. The way you would derive the charge for lead is you have to say, okay, is there any of these I definitely know the charge of? Well, sulfur is always in group 16, and everything in group 16 has a 2 minus charge. Whereas lead, again, is a transition metal, so it has several charges it could have. There's several charges it could have. But the only way PBS balances is if it's 2 minus versus a 2 plus. That's the only way it would balance out. That's the only way, is if that lead is a 2 plus charge. So in that way, you would know this lead is 2 plus. You would say lead 2, and you can't call it lead 2 sulfur. That doesn't work. That's not how we properly name things. We call it lead 2 sulfide. Keep the IDE ending. You have to have that IDE ending to name it appropriately.